Hi, my name is Sittargautam and I like Gobi. My metric number A165757. Today I'm going to talk about Coulomb's law. If two objects have electric charges Q1 and Q2, and if they are separated by a distance R, then Coulomb's law says that the electric or Coulomb force between these objects is K Q1 Q2 over R square. K, which is right here as K sub E. E for electrical is a constant approximately equal to 9 times 10 to the power of 9 Newton meter square per Coulomb square. Now, matter can be electrically charged. Charges can be positive, negative, or neutral. If an object is neutral, it has zero electrical charge. Here's the representations were used for a positive charge, a negative charge, and a neutral charge. Coulomb's law says that like charges with same sign repel each other while opposite charges attract. Now, the closer two charges are, the stronger the force between them will be. So, let's return to our positive and negative charges. When they are far apart, like we show them here, the force between them is negatively weak and indicated by the short arabs. As we move the charges closer together, the forces get stronger, which shows by the arrows getting longer.
Now, in other words, this is the example of the both charges Q1 and Q2. If we increase the charge Q1 keeping the Q2 unchanged, the force is obviously increased. If we decrease the charge Q1 keeping Q2 unchanged, the force is obviously decreased. According to Coulomb's law, force F between them is directly proportional to either Q1 or Q2. By another word, F is proportional to the product of the Q1 and Q2. Now, by keeping the charge fixed at Q1 and Q2, if we bring the charge bodies nearer to each other, the force between them increases. And if we take them away from each other, force between them decreases.
My name is Thanish Ananth with the metric number of A166389. As a continuation of Coulomb's law explanation, I'm going to explain about the K constant in the formula. The force will not be the same for every medium. Variation of force according to the medium is determined by a constant called K. In SI system, F equals to Q1 into Q2 over 4 pi epsilon 0 into epsilon r into r square. Force acting between the charges are expressed in F equals to Q1 into Q2 over 4 pi epsilon 0 epsilon r into r square, where epsilon 0 is the permittivity of air or vacuum and its value is 8.854 times by 10 to the power of negative 12 farads per meter. Epsilon r is the relative permittivity of the surrounding medium in respect to the permittivity of the air or vacuum.
Okay, so we developed our GUI using Matlab App Designer. So basically, Matlab App Designer is very easy to use to develop a GUI. Therefore, we developed this GUI to demonstrate the relationship between the electrical force F and the 1 over distance R between the two charges, which is Q1 and Q2. We added callback on the start button here. You can see at the code view. There for the start button, we added the callbacks. Q1 is for charge 1, Q2 is for charge 2. And then the slider D is used to adjust the distance between the two charges. K is where we insert the constant value, which is 9 times 10 power 9. In here we insert the constant value, and then I'll show you how to use the GUI here lah. We run the GUI. So we developed this GUI based on the Coulomb's law equation, which is displayed here on the screen right now. So first, to run this GUI, we set the value of the charge Q1 and Q2. So here we assign both charge value to be 20 and 20, and then we set the distance. and then we insert the constant, which is 9 times 10 power 9. Alright, and then we press the start button. Okay, so it is shown here the relationship between the force and 1 over distance is directly proportional. So let's try to change the value and also the distance. Alright, so it is shown here no matter how big or small the value of the charges is, and also how far or near the distance is between the two charges. It is shown on the graph that it remains directly proportional. Therefore, the relationship between the force and 1 over distance is directly proportional, proving what is stated inside the Coulomb's law. Thank you.